Yeah, it's at the hour, so let's get started. Let's see if this still works. Yes. All right. Hi, everybody. My name is Rob. I'm very glad that you're still here looking into how we can use GitHub Actions with security in mind. Since this is a security conference, I do need to prefix this a little bit. It's not so much implementing security practices with GitHub Actions. It's just focusing on GitHub Actions themselves. We all run in CI/CD pipelines these days. At least I hope all of you are doing something with DevOps there. I've been using GitHub Actions since the beta in 2019, and I've always been fascinated with my CI/CD pipelines of how the hell do we secure those things. And then when something new comes along, GitHub Actions, then that is something for me to dive deeper into. And that is how this session came to be. But before we get started, who here is already using GitHub Actions for CI/CD or other things? Just a couple of hands. All right. Then I'll give a little bit more insight into what they can do and what you can do there with them. Yeah. So to get started, it's nice that GitHub made a product name and they named it GitHub Actions, and the things that you actually run are then actions. But the file that we store, we call that a workflow, because the workflow is what we used to call a pipeline. So naming is hard, even at GitHub when it wasn't yet part of Microsoft. Now they are, so you could say naming at Microsoft is hard, of course. But the workflow is our pipeline definition that we have. And they will execute one or more actions for us. And the workflows are triggered by events. Anytime something happens inside of GitHub, it can trigger a workflow, and that is why we call it a workflow and not a pipeline. Usually CI/CD systems, SHA+Dependabot, for example, or GitLab, they have pipelines because they are focusing on CI/CD. With GitHub Actions, it's a generic workflow, and you can do lots and lots of cool things with it inside of the GitHub platform. From there, you can call different APIs, call out to your cloud platform, for example. And for that, we have lots of events available. I think there's 35 different events that you can trigger your workflow with. When somebody creates an issue, when somebody comes in on the pull request, you can then do something with that. So it's great for automating everything that you can. And that's a difference from other CI/CD systems. The actions then themselves are the small steps in the workflows. The small building blocks that usually do one thing and one thing only. In the basis, it's just a shell script. They will start, execute something for you, and then you can do the things that you need to do. If it's a deployment into your cloud environment, if to run a static security tool, for example, in the basis, it's all scripts. You can create your own, but you can also use an existing one from the marketplace. That means we have those building blocks available in the platform, and you can build on top of that to create your entire workflow file that does something for you. For example, your CI/CD pipeline. And in there, you can include your static code analysis tooling, for example, and do something there. We currently have 12,500 actions available in the marketplace. This is the way that GitHub, of course, works. They say we have something, and we create that as an open source module. And the whole community can then help improve that setup and contribute actions back to them. From now, we've seen an explosion. If you compare this to Azure DevOps, what I was previously working with, there's something like 3,500 extensions in the marketplace. After all those years of TFS, VSTS, and Azure DevOps in here. So this is an explosion using the power of the community. Anything you can think of, it's probably available in the marketplace. You can readily download it and start using it. At least that's what all the demos say, and that's what I'm here to tell you. Please try to not do that if you can. An example of a workflow definition. I picked something that I work a lot with, that's .NET Core. And it starts with that file. It's a text-based file, which means it gets a part of your repository. And it has history. And from the history, we can do diffs, and we can all do the good practices of having multiple people to review changes, for example, take ownership over those files. And it has to be stored inside of the .github/workflows folder. If any of those things has a typo, it will not work, and it will take you 15 minutes before you figure out how that happened. Ask me how I know, of course. It's a text-based files, YAML, so indentation here matters. My guess is that people already know a little bit about that. You can see the trigger in here. In this case, we're triggering somebody pushes code back into the GitHub repository. And from there, you run one or multiple jobs. In this case, we've got one that does the build and deploy in one job. And we're pushing, in this case, to a label on an environment that we call production. In there, we have an array of steps. And the steps are then the actual building blocks. And whenever it's a user statement, that means that it is an actual action. And actions are stored inside of a repository. And you can start building on top of that. If you see a run command, then it's just a call into your shell. that the runner is executing for you. I think I even have that in here. I start with the most used action that is out there. That's the checkout action. Download the source code of the repository that you're running against. Download all that on your runner environment. And then you can start doing things. This already is the main difference with other CI/CD systems. Most CI/CD systems say we start at your source code. So you don't have an opportunity to say, I don't want the source code because I'm automating something else. In GitHub, you need to specifically say, I want my source code, otherwise I can just run a different script without downloading my repository. Then we have a setup action. In this case, it installs .NET Core with a specific version for this demonstration. And then we run the shell script. Please execute me a .NET build. And there are more stuff beneath this, of course. But this is the overall example of how a workflow is structured and how it operates. So for the people who haven't been using actions, you now at least have a vision of how these things work and operate. If there are questions in between, just ask them. I can try to help there. So for the security perspective, I want to dive a little bit deeper into the main 3 topics on top. How can we secure our repositories and who can write to them? And what is in there? We'll dive also into the runners. Those are the things that are actually executing your workflow files. On DevOps side, it was agents, for example. I think in GitLab they're called runners as well. Then we look into actions and how you can do secure operations there. And from that, I've got some best practices that I always like to advise people to follow along with that. But first, repository security. And it all starts with who the hell has access to our source code? Who has the authorizations there to create things? And this is a little bit of an easy overview there. Inside of GitHub, we have always access levels that you can set up at the lowest level for the repository. You can say for this repository, that person can write to it, for example. And then you have a roll-up to organization level and then even a roll-up to enterprise. In that setup, you have different permission levels. And it starts on the top with no access. But if you have a public repository on github.com, anyone who can go to that page doesn't have any access, but they can already see your source code. So they can start diving into what are the components of your source code and see different attack patterns, for example. They can try to figure it out. Anybody has read-only access on public repositories as soon as they have logged into github.com. And with read access on that level, you get access to anything inside of the repository. The source code itself, the history that is in there, but also the log files when you're executing your actions. So be very aware when you run a public repository that those log files will be visible as well. On top of there, we've got triage levels where you can actually manage some issues and do some triaging there, but you don't have write access yet. And the maintain is interesting because that's between full access as an admin and write access, but they don't have access to sensitive data. For example, security alerts coming from one of the security tools inside of GitHub. And they cannot do things like deleting releases from a repository or rename the entire repository itself, for example. It's really easy to start configuring access and see who has access. If you're on the organization level here, I'm here at a community event that we do every year. Under the People tab, you can find some information there. You can create teams, and from teams you can see who are the people who have access in those teams. If you then dive in deeper into a user, you can go to the user itself and find out that, hey, this person is owner, that's my account, on that organization. That means that it has admin access to all the repositories in that organization. And then you can even specify the list of those repositories, specify the teams that that person is in, and find out more information. In this case, since I'm admin at the org level, I can see every repository that is in there. But it's a good start to at least know who has access to your source code. Yeah, question?
You said it was read-only access like on a public repo, but
yeah.
Is it the same if you have a private?
No, then you need to be logged in, and only then, if you have access, then you can see it. So there are 3 different levels. It's public, that's the default one. Private is only if you have been invited, and you have an internal one. If you're part of an organization, then you can see all the internal repositories. Yeah, good one. If I don't notice your hands, very hard for me to see with the lines here, so then shout out. Second step is workflow secrets. We've seen this in different CI/CD systems as well, and GitHub Actions has a secret store as well that you can use. But it's very good to know how that thing works. It's really warm here, so let me see if I can do this without killing the audio. Audio still on? All right. The secrets, you can pull that in. It's a text-based file, so we have weird annotations with accolades and a dollar sign to pull in a context, and then a constant name, in this case the name of the secret. And then you can pull in the value of a secret, stored in the secret store, into the execution runtime of your environment. You can create these at the repository level or at the organization level. And they're actually secrets. They're encrypted client-side with a public key before they are ever reached GitHub, before they reach GitHub on their side. If you have the level of access that you need to be able to create a secret, then you can download the public key. You need to encrypt it with the REST API before you can post it. So it's an actual secret stored in a Libsodium box. And it also means that you as a user cannot decrypt it. There are other CI/CD systems where you can still pull out that information, like GitLab, for example, and after the fact read out what the value of that secret is. So this is nice. This is actually a secret. And if you use GitHub before, then you know any public repository can be forked. And that means that extra metadata, like the secrets, are not getting forked with that fork over. So what the person who forks gets is only the source code that is in there and nothing of the history or the logs, for example, and also not access to your secrets. And creating secrets has some stringent requirements before you are able to do that. So you need to be a repository owner, then you can create secrets. And you can update and delete them. So anybody who is a maintainer doesn't have access to the list of secrets that they can use, but they can still implement the workflow file and get those values inserted into the workflow as well. You can also create them at the organization level. That means you need to have admin access to the entire organization because in there you can set access policies. Which repositories are able to see those secrets and what can you do with them? You got those three options. You have access for all the repositories or only private ones or a subset of them. And it's nice because then you can do other aggregation at the organization level. You only have to maintain one version of the secret, and if you do some key rotation, you can do that there as well. Well, I said they are encrypted, but only until you start using them. And this is a downfall of most CI/CD systems. And I don't see a way around that. When you start executing your workflow, you need access to those secrets. So you need to start injecting them into the process that is executing, in this case, the actions. And they're either injected as an environment variable or as direct input for an action. Each action on this side lives inside of its own process on the runner. And we give that process then access to the secret in this case. GitHub tries to redact that secret value out into the logs. They do a regular expression there, and that means they're using a regular expression there. And that means if you use structured data with spaces in there and accolades and XML stuff, that's very hard to redact. So be very aware of what you input into those secrets. If it already has multi-lines, then you need to start thinking about it. And as I said, they're injected as plain text for the actions, which also means the actions can do anything with them. They can decide to spool that off to a third-party API endpoint, and all of a sudden your cloud keys are now gone. So be very aware of what kind of actions you implement inside of your workflow file. And as I said, anybody with access to the action log, so any authenticated user against the public repository, and that's usually the modus operandi of open source, it's a public repository, they can see those log files. And if you're inputting there JSON or other structured data that might be an issue to redact, then all of a sudden those values might be visible. I've got an example here on the left-hand side, echoing out a secret, the demo log in this case, and then on the bottom line I'm doing something sneaky. I'm adding a space after each character in the secret. Yeah, go ahead.
Could you repeat which user or which account, like a public and whatever, had access to the action log?
If you are logged in to GitHub.com, you got access to public repositories and their action logs. So you can see those logs. And getting an account on GitHub.com is really just giving them a username and a password and then you're in. They don't even validate the email address at the moment, so it's really easy to get a user account. If you start doing things, then they will need to validate your email address. But creating an account is really super simple. What happens when I echo out that value? The first one is actually obfuscated because they've output those stars because the regular expression worked. But if I do something simple like adding a space after each character, the regular expression fails, and now my secret has been stored, has been leaked into the log file. So be very aware of what you try to do with those secrets. What we currently have is, for example, if you want to deploy into a cloud environment, we have an OpenID Connect situation there where you can configure that at, for example, the resource group in Azure. And you can say this specific workflow file from this repository and this branch can publish my application into that resource group. That's a way better situation to start using. But we're only building up that momentum right now. It's not available inside of GitHub yet. So if you're using secrets, be very aware of what the actions are doing with them, because it's really easy to spool them out into the log file. And we have seen cases where developers say, I don't have the keys to deploy into production, it sucks, I have found a way to output this into my system. And it used to start with base 64, but this is a way easier trick and you don't have to decode it. So be aware of what you do with those secrets. And that's only for access to your code and the workflow secrets. Even worse, you store your own code inside of the repository. And with your own code, I really mean anything inside of your repository. That will be available for the workflow when it is executing. It starts with the definition of your workflow file. What kind of actions are you using? What do you download there? The runner that is executing your workflow will see the list of actions that it needs to get, and an action is stored inside of a public repository. The first thing that the runner does is download that entire repository into the execution environment and starts running from there. You download an entire repository with all the source code in there, all the repositories. If there are binaries in that repository, the runner is downloading that for you. So be very aware of what you put into your workflow files. Even the shell scripts that we make for our make files, executing the builds for ourselves, those are potential attack factors as well. Even your own code, you never know what kind of developers you have in the house. Do you trust them fully to do everything in a good way? Even if they're gruntled employees and leave in the next week? Be very aware of what is in there as well. And then, of course, dependencies. I've talked about this yesterday in a session on supply chain management. We don't reinvent the wheel, I hope. You build on top of packages. Most of those packages are open source. And you start using them as well. But we need to be aware of what is in those packages as well. So it starts with some static code analysis on your own code, but also some validations on the packages that you use. Supply chain management issues are becoming more and more worse. And depending on which research you follow, you could say that 99% of the code that you use is not yours. It comes from those public packages, because they are usually entire libraries of stuff that you don't want to write yourself. It also goes for the whole supply chain setup. Your dependencies need to be kept up to date. We probably all heard the term bit rot. As soon as you deploy something to production, it's probably already too old, because there's a newer version already available. And that version could be fixing a vulnerability that is in there. Step one is knowing what your application uses, also for your workflow files. And from there, figure out what those dependencies are doing for you. Matching them against the known vulnerability database and keeping that stuff up to date. So some best practices there. I hope you are following these at least. Make sure that not a single person can do things. Depends on the maturity of your team. If your team does the entire day pair programming, or they're so mature that you can trust them, that helps. But the amount of times that I've looked at my own pull requests and found some issues there, even if it's just a typo, I cannot count them anymore. So it happens to all of us. So it's best to at least have a fresh set of eyes going over that. Or do something in the pull request to actually validate the things that you're merging into your main branch. Have that branch protection rule there. It used to be the 4 eyes principle from DevOps, but there are people who don't have 2 eyes, so I prefer the 2-person principle now. It's a little bit more inclusive. But run something there. Validate that your application still will do the things that it should be doing. Maybe not necessarily just in the build step, but it could be a temporal deployment where you actually validate that everything still works. And in the build step, run at least a unit test, for example. Figuring out who made these changes, and since your workflow file is in there, this is really important. For the code, you can go back to the Git commit history. Your workflow file is part of the code, so you can find out who made changes there as well. You have a pull request attached to that, so you can figure out which 2 people have committed that change and approved that. Everything that is around your code is stored inside of the audit log. Inside of GitHub, that's really easy that it's there. On other platforms, you sometimes need to search for it. And then the audit log, you can go to a repository, in this case the organization, go to the audit log through settings. And then the audit log is anything that is happening outside of the source code realm. Who gave somebody access to your source code? Who made changes there? Who created a personal access token to do something with that source code? Even inside of GitHub, when somebody enables a feature on the repository, like enabling discussions, that is stored inside of your audit log. You can output that into your SIEM, and your SIEM can make some analysis there, figuring out what is happening, the normal patterns, and then the outliers can be triggered, for example, triggering an alert. That information is available inside of GitHub. So be aware that it is. This is an example on the account level. This is my account. So if you go to settings, and you can find it under the security log. They named it differently there. But also for yourself on your account, it's very helpful that you can see what is happening there. All right, that was just your repository and everything that is in there. Oftentimes we still forget that because we're focusing on the platform or the things that we run or just the supply chain, but your code is just as important in preventing all of those supply chain attacks. Let's talk a little bit about those runners. The runners are the things that execute your workflow files. There's some compute somewhere, and you got two options there. You can run them on a self-hosted setup, where you install a virtual machine, install a runner on there, and from that start executing. And we also have GitHub hosted runners, where GitHub is hosting the compute for you, and they do everything for you. And that comes, of course, with responsibilities as well. If you have a self-hosted runner, that means that all the operating system things that you need to update, but all the tools that you install there as well, are now your responsibility, and you need to fix it. It's nice that it enables you that in a specific environment setup. The GitHub hosted runners, for example, currently don't have GPUs, so if you do something with machine learning there, then you probably have a good reason to start using self-hosted runners. There's also no usage limits on there. For the GitHub hosted runners, you need to pay for the compute because they're maintaining that for you, of course. You pay that by the minute. You've got some minutes in the package that you have. So if you have a Teams account, you got some minutes in there. I think Enterprise usually has 50,000 minutes a month that you run on. And if you go over that, then there's a fee that is implied. But that means that all that operating system and the tools and the security updates are now GitHub's responsibility. So in part, you're paying for that as well. But it gives us at least an option to use that. If you use self-hosted runners, but also for cloud platform, you need to start thinking about security. And on the face of it, I trust GitHub that they can do lots of cool things, that they have a good security team, but still, it is running somewhere, and we need to be aware of what happens on that environment. Especially if you run them yourself, you need to be aware of the scopes that you give that runner. What can it do inside of your network? Is it behind your company firewall? Because you have a test that needs to test against the database. Something simple, it happens. But also think about persisting state between runs. What if it outputs your the binaries, the artifact that it delivers, and outputs that to a network share? I've seen companies doing their whole CI/CD system on a company-wide shared networking share, where they said, well, we just pick up that library from there and we start executing it. If you have a self-hosted runner, that is your responsibility. And also for the user that it is using, of course, if you give it networking access, it can start traversing the network. As I said before, the runner will download the entire repository of any action that it needs to execute, with all the binaries and everything that is in that repository. So be very aware of what that action is doing for you, because it will download that behind the company firewall and will stay there until somebody cleans it up. One of the options you got there is to run the action itself inside of a container. In this case, we're spinning up a container with Gradle in it, and that will do all of the things that we need to do in there. This is one step. But you can also do that on the job level. The job here is test box, and all these steps in here will run inside of this container. So the checkout will download my source code inside of the container, and then I can run and check which Java version we're using. Very helpful, because it also means that I don't need to install Java on my runners. I don't need to install pre-prepared machines there, because I tell my users, use that specific version. Hopefully this comes somewhere internally and has been checked and authorized as well. Use something like Artifactory and X-Ray, for example, to know vulnerabilities in those images as well. But the nice thing is, this is a container. So it spins up, does its thing, and afterwards we just clean it up, limiting the attack factors that you have on the runner environment. And I cannot repeat this enough. We still see this happen. If you have self-hosted runner, never, ever, ever use that blankly for public repositories. You can have a trigger in your workflow that says, when somebody sends me a pull request, I start executing the workflow file. And since it's a public repository, anybody can create a fork and send in a pull request. They can even change the workflow file for you. And then you're running that code, downloading the action on your private runner behind your company firewall. So hopefully you're thinking about this and doing this in a sandbox part of your network. But we see companies over and over making the same mistakes. Run it somewhere in the network with too much access. So be very aware of these responsibilities that you have setting up the CI/CD system with this. This is an example, of course. You have got your repository, somebody creates a fork, adds that malicious code, creates a pull request, and now that workflow executes on your self-hosted runner. With all the access you gave it, and all the networking stuff that it has access to, but also potentially access to your secrets, your cloud deployment keys, any SSL certificate that is installed on the machine. This is for the execution part. Persisting data between runs is just as dangerous. Not only the actions are being downloaded, but if you output something, for example, you use a dependency cache locally because your package manager supports that, it does speed up your build because you've got a cache there. But the second run could override those cached versions, and then the next build will pick up that malicious dependency, and now you've got a malicious dependency in your artifact. And you might say, that doesn't happen. We're at a security conference, right? This is exactly what happened with the SolariGate attack. This is a super interesting read on the depth of things that they did here. This one is case sensitive, so be aware if you use that. I'm sharing the slides afterwards anyway, so then you can click on it, that helps. But this was super big attack that we've seen where they did exactly this. They even went so far that they detected when there were processes running on the machine that could potentially detect them. And in that case, they shut everything off, and that way they evaded detection for 2.5 months, I think. They overrode, I think it was one binary. They had some extra attack factors there. They overrode one binary, and that got included in the build artifact. And that artifact got delivered to 3,500 customers who all updated to the latest version. So this is a real-life case that you need to be aware of. And that's why I'm so hammering on we need to update our CI/CD pipelines and make sure that we know what is happening inside of them. And GitHub Action is one of them, and they have the same issues as other platforms as well. I'm hoping to at least instill that message in you. You need to be aware of what those things are doing for you. Similar for that, don't share those runners. You can say, I create one virtual machine, I install 10 different runners on that, and now I can share the compute. We used to do that. Hopefully you can see the risks here, because those runners have too much access on those machines, and they can start escaping the sandbox that they have. They can override the package cache centrally, because they're centrally managed on the virtual machine level. So have a way to use a runner one time and afterwards clean it up. That's what GitHub does for the self-host or for the GitHub hosted runners as well. They only exist for one execution run, and afterwards they get cleaned up. There are ways from the community where you can spin these up inside of a Kubernetes cluster. It will only exist for that one execution, then it dies and we spin up a new one. So be aware of all of those risks. That was only the hosting part. Now we need to dive into the actions. As I said, the actions are open source. You can use them from private or internal repositories. That's a little bit more secure depending on who's creating them. But by default, those 12,500 actions that were there, those are public repositories. That means you can go in there, figure out the history, who's working on them, and build on top of that. They don't need to be published to the marketplace. Any public repository will work. So the attack factor is even worse and larger. You can go to the marketplace, then you can say, I want to use the latest version, and then give you a pop-up that says, well, if you copy and paste this part over, then you dump that in your workflow file, and you're good to go. This is each and every single demo. The nice thing is that that users part, you can pick up that part and paste it behind github.com, and now you've got the direct URL to the public repository, which means you can see what that thing is doing. Start at least there. This is already where the demo stops. They say, hey, copy and paste this, and then you're good to go. I'll first figure out what the hell is in that repository and what's actually doing for you. They also have a version attached to that. This is now the default. It used to be optional, but you need to attach a version, and this follows semantic versioning. So the first version indicates, in this case, version 0, they're still building it up. This is a minor, and this is a patch. Anytime those last two numbers update, it's always backwards compatible. But if there's a breaking change and the first number changes, and you need to make a decision, there's a breaking change, can you absorb that change? Important for an upcoming slide. As I said, this is a public repository. What the hell are we executing to build our own software? So I'm not even talking about all the vulnerabilities in our own software. This is just our pipelines. And the more I dive into this, the more scary that I find this. And this is why I hate that all the demos stop at just copy and paste the example. Well, we're downloading a repository. There's nothing on the repository that tells us this has been validated by somebody. It's up to you. We rely on the open source community here, and you're part of it as soon as you start using this. I already mentioned some of these attack factors: data theft, exfiltrating, SSH keys on the machine, data integrity breaches, of course, but also availability now. We've had those outages the last couple of weeks with GitHub. All of a sudden, you couldn't download your actions, which also meant all of your runners failed. Even if you have self-hosted runners, even if you're using enterprise server on-prem, they were still downloading the public repositories. With that, as we are all doing CI/CD, if I find a 0-day on your application and I know that you're using GitHub Actions, I now got a targeted way to block you from updating your production environment. Now, this is where it starts. Figure out what that action is doing. There is nothing to protect you there. Go to the action repository, figure out what it's doing. If it's using container images, any dependencies, most of the actions run on TypeScript. And we've seen that a couple of times now in supply chains. Those packages will use packages, those packages will use packages, and I can go on for half an hour. We have that whole supply chain there that we need to be aware of. So the first step is at least start looking at those things and figure out what they do. As I said, that users part, you can copy and paste that behind github.com. If that is a public repository and it has an action.yaml in there, you can start using it as an action. And this is, of course, the most awesome thing since sliced bread. Non-harmful, you must use it action. Guess where I got that example of adding spaces in your secret? Public repository, specifically not published to the marketplace to make a point, but it is there. If you go to that repository, then there's a nice banner that says, hey, you can use this one. This one is on the marketplace. You can search there. So my initial reaction was, oh, awesome. There's a marketplace, so there should be a verification process. Azure DevOps at least pretends that it has a process. If you publish something, then they wait a couple of hours before it is available, so they are doing something. In this case, if you start an action and you publish it to the marketplace, it's instantly available. Go ahead.
When you showed the AWS workflow, it had like this verified banner under it.
Next slide.
Okay, sorry.
Ah, that's fine. Yeah, I'll do that in the next slide. So the marketplace doesn't really have a verification process. So what are we doing? We're pulling in a random repository, maybe behind your company firewall. You can go to the marketplace and there's a check mark there. And we've all learned from the internet, check marks are indicating that this is great. You can go there and it says, well, this is created, that action, that repository, comes from a verified creator. When this started, I started looking for what the hell does that mean? There's a link there. That doesn't give you any information what it means. Eventually, after I think it was a year and a half, they published a page on how to become a verified creator on the marketplace. You need to have your GitHub profile present and accurate. That means you have an email address and that has been verified. The organization that publishes the repository, that needs to have two-factor authentication. So all of a sudden it cannot be a personal repository anymore. You need to create an organization. And that has two-factor authentication enabled for the organization. So anybody who's contributing in that repo needs to have two-factor authentication. Okay, that's a good point. And that organization is linked to a domain. And that is verified through a text record. I think you're all aware of how easy it is to get a domain, add a text record, and then say, I'm verified. I went through this process myself because I still didn't believe it. And this is exactly what it is. Was even nice because I went through these steps and there's a click that says verify, and they told me, yeah, you're now verified, and wasn't showing up anywhere. I had to make a call to some friends there, and they said, well, we need to do something manually, and now the check mark is visible. So that check mark is not good enough. You can go into your organization or the repository or even the enterprise, and there you can set permissions. You could say, I'm now so scared that I'm going to disable actions entirely for any repository because this is weird stuff. Well, the option here is, of course, allow select actions, and those should be pre-populated with the actions that you have actually validated. The default checkmark is already saying allow actions created by GitHub. There's no reason in the documentation anywhere that indicates what this means. Is this in the /GitHub organization? Is it in the /actions organization? Is GitHub the maintainer of this thing? I sort of trust them, but if they don't have a transparent process for this, I hate it. I think I even have that one. Verify creators, I think that was clear. I really don't trust that. They say that in the documentation, you trust us on blue eyes. Well, I don't. So the better option is to say specified actions. And you've got a whole scala of wildcard options here where you say, I trust actions from that organization because I know the maintainer. You can even indicate specific action repositories there and even specific versions. So that's at least a good way. You went and did the work, verified that version and said, well, okay, I've seen the code and now I can trust that, right? If you enable specified actions at the organization level, for example, and somebody creates a workflow and tries to trigger that, and it doesn't match your allow list, then you get an error indicating go back to somebody with admin rights on the repository organization level. Call that person. That's very nice. So at least we've got a sense of we have secured this a little bit. As I said, this uses semantic versioning. And initially, in the first half year, they said, well, please start using the action version and pin that. Pinning is just including that @ sign and the version name. We're using semantic versioning, so you have the freedom there to use this as a filter. When somebody updates this package to 1.02, this one will download the new version and this one will not, because you have pinned that version to something. This is very common. Only thing is, this version comes from the releases inside of GitHub. And you create a release by creating a tag in Git. And then you push that as a release. And now it has a tag inside of your Git history. Should be fine. Well, the problem with tags is you can reuse them. I can add code in a repository, use the same tag, and push a new release with the same tag. So even if you use the full version for pinning it, this will still download randomly new code that you haven't verified. So this is still super scary. If you're using that version, then you're already gone, because you're pulling in every new version. It sounds nice, but you're pulling in weird code from the internet. Go ahead.
Your previous slide said it could use SHAs as well. If it uses SHA, I guess it would be more.
I came prepared. So this is the best practice that I say start with. Start with verifying what is in that repository and add the SHA hash. Please, for the love of all things, start here. Then at least you can say, I'm doing something with security because I'm doing the effort of outputting that SHA and adding it there. Initially, it was even the short version of the SHA, but they quickly realized that that was not good enough. So this is the entire SHA. And this is unfortunately hard to read for us humans. So what's next? Even better, start taking ownership of those things. Allow that to local actions in an organization or only select actions from an organization that is under your control. This used to be the starting point for actions, but now in each and every demo they just gloss over that. Create a separate organization and fork that action over there. That means that nobody can add code anymore to that repository. It's now under your control. You still get notifications if you set it up correctly that the maintainer has pushed updates, and then you have a way to validate those incoming updates. At least you now have a way to control those things. That's coming up next. Because we're talking about these types of attack vectors. Forks of public repositories, and somebody can send in a pull request, and now all of a sudden your workflow is doing something else. But also through common fields in those workflow files. It's a CI/CD pipeline, so it probably has parameters somewhere along the line. This has at least already improved a lot. There are 3 different types where you can start running code. a push, but on a fork that only runs on their end. They need to enable the workflow on their end and then it can happen, so it's relatively safe for us. And on the pull request, when somebody creates a pull request from a fork and you have the pull request trigger, that will trigger your workflow file on your environment. But we learned the hard way that this is insecure because we're now pulling in changes from a fork. And we said, well, this only runs on the server on the merge commit and will only get read-only access to things like our secrets. Initially, we just gave it the secrets and say, hey, you can now deploy into a cloud environment. The pull request target is then the newer one, and that has super high risk. It will have read and write access, so we inject the secrets there. And what we usually say, protect yourself. Start with the first workflow to indicate we did a check. We did, for example, a verification on the YAML file. Try to remediate the risks, and then you can say, I still want to run on the pull request because I need to validate it on our own test environment, for example. But you need to have a check in front of that. This is a super interesting read. Every now and then a while, GitHub has captured the flag events for actions as well, and they say, here's a repository, try to get write access into our main branch. The things they learn from that is super interesting to see what we can learn trying to protect ourselves from these types of attacks. For the pull request, I already mentioned secrets. There's a secret, a specific secret, the GitHub token, that gets instantiated for each and every job. And as soon as the job has completed, this one has been revoked. But that token has, by default, read and write permissions into your repository. So if this comes from somebody who has write access into your repository, they can do things with that. It's very easy for automating things. I can create a comment on an issue by using the GitHub token. I currently don't like that this is the default. Of course, it should be as less actionable as possible, and then I need to decide, do I want to give it? So be aware that this is the default. What you then can now do is give it less permissions, give it more granular permissions by defining that in the workflow file. This is now all of a sudden source code, and you can say that a GitHub token can be created, but it has only write access to a pull request. So we can add comments to the pull request in an automatic way. It doesn't need to have write access into my contents, preventing me from creating extra commits in my repository from a workflow file.
If you give pull request write access, can it be automatically merged by this workflow then?
I'm not 100% sure if this can be used to merge. I don't think so, but I'm not 100% sure. That's a good one. I think it only has access to the pull request itself, so the body and the comments that are in there. But I'm not 100% sure. But then at least the token that you inject inside of an action, that will only have that, so limiting the blast radius applies here. Try to confine it as much as we can. Through those captured flag events, we've also seen attacks through all of these types of fields that you can use. It's very nice for us as automators. I can read the title of your issue that you're inputting, but this is user input. I've seen several sessions at the conference that say don't use user input. Don't trust it by default. Got an example here of an action, in this case is a shell script, that uses the title from the issue that triggered the workflow execution. And I do some regular expression with that to figure out what I need to do, and otherwise I echo something out. Well, that part is of course interesting. This is all done by string interpolation. So if I give it this payload and end that string a little bit early, now I've got actionable code inside of my shell script. Super simple, but this is user content, so do not trust it. We've seen a capture the flag event where somebody had crafted a specific name of a branch, and that way they got write access into the repository by escalating their privileges. This is a way to prevent that. Make sure that you inject it as an environment variable, then it will not be interpreted, and you can use single quotes, of course, on a shell script to make sure that it's not an interpreted string. That's a really simple mistake to make. So that part was hopefully scaring you all a little bit. Now I've got a way that I use, and I advise my customers to use that as well. We're implementing that currently again at a customer, of taking ownership of all those actions and then have a good way to at least stay up to date and do the verifications that we need to do. Those forking of actions that I mentioned, it has more pros than cons in my opinion, but the cons are really there. It will be more secure because you're taking ownership. You have a point in time where you can do the validation and you can say, okay, I've done that, I've forked it over to my organization, so it's now under my control. It also gives me a nice way of backing that up in case the maintainer of that action wins the lottery, for example, and they go do something weird. You still have a backup. They might rename the action. There are ways to remediate that as well. GitHub works around renaming and moving it into organizations pretty well, but it's just through a redirect, and it happens to work. So taking a bit of ownership really helps there. But it also gives you more maintenance work. You need to create those forks. You need to have an organization that can create an org. You need to have a set of DevOps engineers, if you want to, who are responsible for that and keeping that up to date. And you've now said allow only these actions from that organization, so it's a speed bump of using new actions in your organization. I use an extra organization to test these things out with test code to make it as safe as possible there. But it has some cons as well. This should be a starting point, because then the onus is up to you. You've already done some validations, and those validations usually are manually. Now, I haven't included that in these slides. I've got a blog post of how you can then do all those validations, what we can do to automate that, using Dependabot updates, for example, and stuff like that. But I left that out of the presentation for today, because I can talk for that for an hour as well. Now you got a fork, and now you need to keep it up to date. And that was my starting point initially, and from that you can build out the rest. Because as I said, we have 12,500 actions. It's all open source, and most of them are pretty active. So they update it every other day. Do you wait for a deprecation message on the repository there? We only have a version available inside of GitHub. How the hell can we stay up to date? Do we want to create some automation that updates that with a pull request on our end? You need to read all the changes in that source code repository. And staying up to date is super hard. There's a marketplace and that's it. There's no RSS feed, there's nothing there that was available. And when I started, it was only a couple of thousand packages, so that was still doable. And I was frustrated because I couldn't see what the people in our community are building on top of that. And I'm a good nerd, so I built something for myself. I've got a Twitter bot that tweets out every 3 hours. It checks the entire marketplace, sees if there are version updates and new stuff available. In that case, it will tweet out. This is already drinking from the fire hose because the community is super active in creating these things and updating them. But still, the new stuff that I've learned already in here, new technology that I haven't heard of before, it's cool stuff. So this could be a way to stay up to date. The other way is going to the marketplace and then do a diff on the number of actions that they say are there, and then start searching for them, of course. So this is a bit better, but this is interesting to see what pops up here. The better way is, for me, split into two options that I want to give you. It always starts with review what the action is doing. That should be your starting point. Do not blindly trust an action repository. It could be hidden inside of the history somewhere. So super scary. The first one is use actions and a commit SHA. We've shown that. Pin the commit SHA, that's a good practice. At least start there. If anything else, then this can already help you, but do the verification first. Then you can add Dependabot. Who here already uses Dependabot and knows what it is? Okay, a bit more than actions. Dependabot is basically a dependency checker. Dependabot has this whole software composition analysis of your application, but it can also do that for the ecosystem GitHub Actions. It can read all your workflow files. It's easily stored inside of a specific directory. It has the same schedule as a normal Dependabot, and it will go through your actions, even with the commit SHA, saying, hey, there's a new version available. I see you use the version tag, so I update, send you in a pull request with that updated version, or with the updated SHA. Super easy. So that's very helpful, but now you're getting pull requests for each and every time one of those action updates happens. Depending on the action that you're using, something like the checkout action, that probably gets an update each and every week, because they're actively checking their dependencies as well. And if the action/checkout action is updated, probably 80% of your repositories will get a pull request stating you need to update your workflow file. So this could be a little bit cumbersome, but at least it is there and it already helps. I already gave away my Dependabot stuff. Dependabot will check your repository, check the actions file, and then here you see an example that it says the TRX parser that I use to output my unit test. It has an update from 003 to 005, and it will then send in the pull request with only that change. They've now even enabled it that Dependabot is showing this as dependencies inside of your repository. which also means that you can go to the checkout action and find out all of the 40 million repositories that are using that action. So it's now bringing visibility into the ecosystem. How actively is this being used? Only works for public repositories where they can show that. But we have that now included as part of the supply chain. So I really like that as well. Yeah, that was the update, of course. Even better is improving this setup, because I don't want to approve 20-something pull requests across all the repositories that I have on each and every Monday. That's a great way to start your week, of course, reviewing each and every time the same pull request. Start by reviewing the action and fork the action repository. You can see that this is a fork, of course. And then you can say, I'm going to wait until this huge banner appears on the repository. But who goes into each and every of their dependencies and checks for their message, of course? That's not doable, so we want to automate that as well. And I'm a DevOps engineer. Search for it long and hard, because I really don't want to try and create everything fixed for every issue that I see, but I couldn't find an option there. And when I can find an option and it really bothers me, then I start creating it. So I've got a repository, the GitHub fork updater. You can fork that, configure it, and it will update all of your forks. It goes through all of the forks inside of an organization. It runs on a schedule, so that's easy. We're using actions and workflows for that as well. It will then create an issue saying, hey, you've got an outdated repository. Click on this information. And you get that message. This is stored inside of the GitHub fork updater, so you can, for example, subscribe to notifications from your DevOps team, and they can all manage that. Give them the authority to do that. You can even create workflow files that then automatically will assign it to your team, for example. You can do all sorts of automation on there. But the important part is that I give you a compare link, and if you click on that link, then it will exactly tell you we're coming from the fork, and we're figuring out what is happening there. On the, it's not even shown here, there's a tab where you can see the actual code changes in here. And this is not a good enough example, I should update that. But you can see all those incoming commits that were made on the action repository. So you can validate again, these are the changes. I made my base validation, these are the changes. Is this good enough? And then you can make a decision there. Making a decision is adding a label. Only people with maintain access can add labels on pull requests and issues. So this is a good security measure. Your team can do the validation there at their own time and add a label. Adding a label is a trigger for a workflow file. So the workflow file can now do the work and update that fork for me automatically. I don't have to care anymore. And it even then closes the comment of comments on the issue and closes the issue, and then we're done. Easy peasy in that case. Yeah, you should then get closed. So this goes back to my list of pros of forking. You've got a backup of the action. You have full control over updates now. You're pulling in all the updates centrally, so you don't have to manage Dependabot in 20 different repositories with 20 different pull requests for 20 times the same action. So you have a level of trust here. And you can then say, I only want to allow actions for my actions organization. Which then also makes my life easier, because now I can say, I want to skip figuring out the commit SHA for each and every action. And then going across all my repositories, doing the maintenance, figuring out if it's there. I have a good security harness now, so I can say everybody can at least go back to version tags, because now it's under my control. I have a little bit more insight into that. So the most important thing is that it skips adding Dependabot each and every day. I've got a blog post with all of those steps in here and all the maturity levels that I've seen there. So if you want to follow along with that, read that. That helps you, guide you through the entire process and where you can learn more. And with that, I hope that I scared you at least a little bit and you woke up. Don't start using the defaults and don't check the demos. Follow up on this and figure out what you can improve there. I gave an overview of all those best practices. This is a nice summary overview. And start there. Those secrets, they're very scary in my opinion. Especially if you have a public repository. Start by looking what those things are doing for you. The runner downloads the entire repository on your end and does something with that. I even have a proof of concept where the first thing in my workflow is my script. And my script will check at all the actions that have been downloaded in the workflow, because that's the first thing that it does. And then I can start overriding them. And currently there's no integrity check after that. So even if you have 10 actions that are executed in your workflow file, I can control what they are doing. tough luck figuring that out if I do it properly and in a good way. I'm still bothering GitHub to fix that, but they're not there yet. Fork the action repository, limit to local actions, make sure that you have it under control. I currently have an environment where we gave 600 developers the opportunity to use any action from the marketplace, and we are now trying to remediate that. Way too late, we're after the fact. On self-hosted runners, so that's even worse, when we need to try to protect ourselves against these. It will create a burden and a little bit of a speed bump, so have an organization to test with, be aware of that as well. Don't just block everything, because that's a way to kill innovation, of course. And then I think I gave you a good way to keep your actions up to date. There are more steps after this. You can set up your own internal marketplace, for example, where people can search in your internal actions. You can create updates from that and newsletters, but that's all follow-up stuff. My main point is think about security in this case, because it's very scary to me. And the more that I learn about this platform, the more scared I am. So with that, if you have any questions, just come over here and ask them. I still have some time before I need to run to the airport and fly back. My name is Rob. I live in the Netherlands. You can follow me on Twitter or figure out what I'm doing through my blog post. There's lots of stuff and actions in there. Thank you so much.